Today I'm going to be showing you guys how to set up this, where any random object pushed into the crystals does nothing. But if I run in, oh boy, they all explode and they just go everywhere. And this right here is just a spawned PCG graph that I'm modifying. And once it's all done and destroyed after some time, it goes ahead and clears up. So you can create a cool little ability or use this for other nifty tricks to get this looking and behaving how you'd like. So with that, let me show you how to set it up. To get started, we of course need to go to Edit and Plugins and make sure we have PCG turned on by turning on the procedural content generation framework and restarting your engine if needed. Once you have that, we will need a few things, starting with a simple PCG graph. I'll just call it PCG underscore ice spikes. And I'll also need a blueprint actor. I'll grab ourselves a blueprint class of a type actor, and I'll call it BP underscore ice spikes. Let's go ahead and open up the BP ice spikes. And here we'll need a few things, starting with a sphere collision. So go ahead and add that in. And this is where we'll also want to change the radius of the sphere right here in the detail panel. And I'm going to set the sphere radius to something like 750. You can, of course, control this amount. This is the one I'm going to go with. After that, I'm going to add ourselves a PCG component and the detail panel in the graph instance. I'll go ahead and plug it in. And honestly, that is all we need here. I'm going to go ahead and take this and just drag it out here. You can see it's quite big. So this is going to be what we're working with. So I'm just going to make a little more room for myself. There we go. I'll have it be right here on the left. And now that it's here, let's open up the PCG graph. Now, the first thing I want to do is create a circle, basically. Now, we're not using a spline for this. So instead, I want to create a spline from, well, just points. Now, you can do this a few ways. The most basic circle you can do with just a single point that you've offset up, right, down, and left, and then you connect them all together, and then you get a circle. Now, the problem with this is, depending on how big you want that circle to be, it won't be very circular per se. So what I would like to do is actually make it be a little bit more precise, but adding in an in-between for each one of these. So instead of having 4 points, you have 8 points, and you create a circle with 8 points. So to do that, all I'm going to do is right-click and grab ourselves a Create Points node. And here in the Points to Create, we can go ahead and add the points, and we can specify the transforms. Now over here, I have now gone ahead and populated all the points. So the points are as follows. First one is at 600, 0, 0. The Z will always be 0, so I'll just be mentioning the X and Y. So 600, 0. Then 420, 420, 0, 600. So we made a 90-degree rotation here. Negative 420, 420, negative 600, 0, negative 420, negative 420, 0, 600, negative 600, and finally 420, negative 420. Now, what does this all mean? If I go ahead and press D to sample it, you can see now we have this circle of points. And I've gone ahead and made sure that they're positioned in a way that, well, they are going to go in order. If for some reason you do not see the points after pressing D here and selecting it in the bottom left corner, just press A once, and then you can turn off A again, because it gets you the point information. And for some reason, after doing that, my points showed up, but before I did that, it did not. So just a little heads up. But don't worry, as long as you press A, you see the points. That's all you really need. You don't need to actually preview them in the world. But now from here, we can go and drag out of here and use a Create Spline node. And we only care about the data, but we do want it to be a closed loop. And then from here, we can go ahead and use a spline sampler. Now, you could do this several ways. You could do it on subdivision. You could also do it by distance. You could do it by number of samples. In my case, subdivision is just fine. So I'm going to do 15 points for the subdivision segment. And then I'm just going to do a simple transform points node. And this is where we're going to add a little bit of a variation to this by adding negative 50 to 50 in the X and Y for the offset, a little bit of rotation of negative 30 in the XY and 30 positive in the XY for max. I'm not going to touch the Z here because then it will combine the Z rotations with the X and Y. And I can show you actually what happens when I do this. So we'll go back to this in just a moment. But just know that we'll probably want to separate this out into its own transform points node. And then the scale min and max, I'm just going to go from 0.7 to 1. Uniform scale is just fine. And from here, I'm just going to drag out and use a static mesh spawner. And I'm going to grab this static mesh crystal that I have. The material on it is extremely basic. As you can see, it is just a simple color multiplied by a per instance random with a little bit of an offset and a roughness of 0.2. So this is just a nice simple material for testing. Let's go ahead and add the mesh entry in here and plug it in. So if we take a look at it, we're getting kind of what we want. Okay, that's great. It's looking pretty nice. What was that about the 360 degrees? Well, if I go back to this 360 degrees here that I have, and I select it and just set it to be 0, you will see it rotated the entire thing with these angled offsets. In fact, I wanted to just rotate along its own axis. Like, I'm fine with the offsets it has. I don't want it then modified again by this 360 degrees. So instead, I'm going to move the static mesh spawner to the right and add a second transform points here. And in this one, all I'm going to do is rotate 360 degrees on the Z axis. And now in this one, if I change it between 0 and 360, you can see it is actually rotating just around itself. It is not rotating and moving these points anywhere except for just around the current rotation, which is what I want. Now, you could absolutely go with this one. It is absolutely fine, but I like to actually rotate them first and then rotate them around the axis. So fantastic. We now have this. This is great, but if I press play, I can just go right in here and just walk through everything. This is not exactly what we want, is it? No. First of all, we want these to block the actual collision. So in the static mesh spawner, I'm going to search for collision, and then I'm going to change it to just block all by default. And now you'll see I cannot come in here anymore. Does not work at all. Okay, step 1 is complete. So now what we want to set up is that I can break these by just walking over to them, but no other object can, like this cube over here. So no matter how much I'll push this into the wall or anything else will, only I will be able to walk up to it and break the crystals. To do that, we'll go ahead and open up the blueprint one more time. Let's go ahead and select the sphere collision, and then I'll search for collision. And here in the collision presets, instead of overlap all dynamic, I'm going to change it to custom. I'm going to ignore everything except in pawn. I'm going to set it to overlap. And now if I right click on the sphere and go add event, on component begin overlap, I can do a simple print string here using other actor as the input to get the display name. And now if I come over here and I push this cube into it, nothing happens, but you see in the top left, when I come inside, it prints the name of my character. We can now detect when it is that a character is going to interact with it. You can absolutely set it up to be the reverse. You can set it up to be detecting the cubes or other objects or whatever you'd like. I'm just showing you one way of doing it. It's of course up to you to implement it the way you want to do in your game. So that's fantastic. We know it's detecting it, but now we need to start working on swapping out these crystals for ones that break apart. But of course, to do that, we need to get some that break apart. So to do that, all I'm going to do is drag out one of these static mesh crystals into the world. And then in the top left, on the selection mode, I'm going to select it and change it to fracture. Then I'm going to press new to create a new geometry collection. And it will just try putting it in the folder you have open already. So that's fine with me. And I'm going to just change the GC_SM crystal to just GC_crystal and then create geometry collection. Immediately we can see this nice checkerboard here. And so what we can do is go to fracture uniform and you can see how much it is fracturing it. You can of course play around with this. We can make it fracture a little bit less, a little bit more by changing these values. But let's say we are happy with the one we have at default. All you need to do is then hit fracture. At which point you can change this explode amount. And if you raise it up, you can see there it is. That's how it looks like split apart. But make sure to set it back to 0. And then you can cancel out of here and go back to selection mode. And now you're good. And we can go ahead and delete this from the level. We don't need it anymore. As you see here, it has created a new folder. Inside the folder is this geometry collection crystal. There it is. And if I was to go ahead and play and take a look at it, by default, it doesn't do much. There you go. I've given it enough force to knock it over, but that's not quite what we had in mind. I would like to knock this over completely and just have it completely explode. So what we need to do is just open this geometry collection and we can make a few small changes to this. Now, I'm not an expert in geometry collections, but these are the values that I found work well for me. Starting with the fact that I want to enable nanite for all the fractures. So I'll go ahead and turn that on. And I also have this removal section here, and I want to do remove on sleep. So once it stops moving after 5 to 10 seconds, it will remove the objects after 2.5 or 5 second transition time. I'll leave it all at default. This is fine for me. So that's all I really want to change here. Now that I've created the actual thing that breaks apart the object, the geometry collection, why don't I just spawn that with PCG? Well, it's simple. I feel like it's a little bit better to spawn just regular static mesh instances everywhere and only make those that you need into the destructible ones. But you can absolutely spawn the geometry collection if you would like to. And I'll show you how right now, in case you do. In case you want to spawn instead of the static mesh, you want to spawn the geometry collection, here's what you do. We'll detach the static mesh spawner because we will go back to this in the end for the rest of the tutorial, but I just want to make sure you know how to do this as well in case you want to. So from here, I'm going to drag out and search for add attribute. And we want the parameter version. And the parameter we want to add is the geometry collection. So I'm going to deselect it, add a new parameter. I'm going to rename this to geometry collection. And the type here will be a geometry collection. And this is a regular geometry collection, not a geometry collection actor, a regular one, object reference. And then here in the drop down, I'll go ahead and select my crystal. So then I can right click, search for get geometry collection and plug that into the add attributes. And then I can go ahead and use a spawn actor. And in the spawn actor here, we can specify the template actor class to be a geometry collection actor. Geometry collection actor right here. And then we want to change the spawned actor property override description. I'll go ahead and set that up. And to know which one we need, I can drag out the geometry collection one more time. And then in the detail panel here, you can see it is called rest collection. Now what I can do is right click and copy internal name. And that gets us what it's called under the hood, not just the displayed version. So we can put that into property target, but we need to put it in a source. Now here we see I've left it on output target none, so we need to change that. Let's just call this crystal. And then back in the spawn actor, I can go ahead and change the input source to crystal. Now it is still throwing an error. Warning, object override for property rest collection is invalid or unsupported. Well, that's odd. We copied this name. Well, that's because, just like on the previous tutorial I did, it is not coming from GC Crystal, this. It is coming from the geometry collection component. If I select it, that is where it is. In fact, if I scroll down here, there is our rest collection. So we want a geometry collection component. So over here in the spawn actor, for the rest collection, before it, I'm going to specify the name of the component. Geometry collection component dot rest collection. Now, if I press enter, the error has gone away. And there we go. We now have all of our crystals back. And if I select all of them, you can see in the outliner, you have all of these separated geometry collection actors. I can go ahead and hit play and you see what happens immediately. Now, why does this happen? Why are they just all immediately falling over? Well, that's because they're physics actors and, well, they're leading. So that's not great. The other thing that I would like to do is change a few things on these crystals. Now, I'm currently being able to walk on them, but what if I didn't want to walk on them? Or what if I didn't want the navigation to be affected by this? If I go ahead and drop in a large navigation volume in here, just to cover kind of the whole area where we're working, you can see that all of these crystals are cutting out the navigation. Now, this might be fine, but in my case, for my game, I want to actually not have it affect navigation, because I want the AI to be able to walk into the crystals and they're the ones that are able to break it. And of course, if they see they cannot walk through it because it is a wall, they won't even try to. So in my case, it was easier to make it so it does not affect navigation and have them be able to walk into it and then trigger all this, sort of like what I'm about to do with my own character, but I did it for the AI. Let's go ahead and do another add attribute, do another parameter here. This time, I'm just going to use a type Boolean. I'll keep it off, and the output target will be nav for navigation. I'll plug this all the way through. Now here you can see can ever affect navigation, right? I can go ahead and right click and copy this, and we know that it's going to be in geometry collection component by selecting it and seeing it's still there. So in the spawn actor, I will add a new spawn actor property override description. The input source will be nav. The property target will be what I've copied over, which is b can ever affect navigation. And we'll put in this geometry collection component dot right before it. And now we should be good. So now as you can see, none of it is affecting navigation. So fantastic. This part is working. If I hit play, it still all collapses down. And depending on how it collapses down on itself, you can see it is shattering completely fine. You know, that is all working. But of course, it's not great. It's still not quite what I want. So let's adjust a few things. Starting with the fact that I want to go back to spawning the static meshes and only convert the ones that I actually want into the crystals. Now, this does mean that we have now the collision set back up. And you can see the AI will not try to go through. But if you want the AI to go through them, all we need to go is the static mesh spawner. You can search for custom nav. And you'll find B has custom navigatable geometry. By default, it is yes. If I set that to no, then just like that, we have ignored it on the static mesh version as well. So the AI will try to walk through it. In terms of this demo, we're going to be walking through it, so it doesn't matter. But if you want to make sure that the AI tries to walk through it, this is one method which you can use to do it. So awesome. We now have static meshes that when we hit play, they all stay. But now, of course, I want to break them as I walk up to them. So let's go back to the blueprint over here. We no longer need the sprint string. We're going to be doing things on begin overlap. And honestly, we're also going to need an end overlap. So I'm going to right click on the sphere again, add event, on component, and overlap. So now we have both of these. And the way we're going to be doing this is when we start overlapping it on a timer, we're going to send a force out from a character that basically destroys these crystals around me. And when we leave the area, it stops destroying it. And because the sphere is slightly bigger than the actual crystals in terms of radius, we will always be inside of that sphere when we're trying to destroy them. Otherwise, no need to track it. Now, if you want to make sure that it is specifically the player that is the one checking this, from other actor, you can drag out. You can uncheck context sensitive and search for is player. You can get is player controlled, which will get you the instigator, and then is player controlled as a boolean. Then you can then just use a bool here and confirm that, hey, it is now only going to do what's after this if it is the player doing this, or if it's AI, you can do it on false. So now I'm beginning overlap on true. We're going to search for set timer by event. We're going to set the timer to looping, and the time it loops is 0.1. So we'll loop it 10 times a second. You can, of course, adjust this to your liking. This is enough of a time for me. And then I'll drag it out from event and search for custom event. And I'll call this check overlapping crystals event. And now we need to know what crystals are being overlapped by the player. Right after this branch, once we know we have the correct actor in mind, I'm going to right-click on this other actor and promote it to a variable and call this overlapped actor. And I'm going to plug it in right after this true. So once it's overlapped and it is the player, I want to get a reference to that player. So now what do we do here? Well, we need to find what are all the instances and which ones are we overlapping? Or not really overlapping, which ones are within our radius. So what I'm going to do is right click and search for get components by class. And the component we want to use is an instanced static mesh component. And then we want to do a for each loop and loop at all of these components. To make my life easier, I'm going to select both of these. I'm going to right click and collapse it to a function. And I'll just call that function swap overlapping crystals. And that's all this will be. And that way, inside of this function, I can use local variables for things like this array element. I'll right click it, promote to a local variable. I can just call it what it is, array element, and plug it in after the loop body. So this is just going to help us manage this. And in case we ever want to take this and move it somewhere else, we still can. So great. We now have all the static mesh components that are in our graph that's generated. In our case, it's only generating the one because it's only one type of crystal, but if you're doing multiple, it could have multiple here. So we need to know what's overlapping. From the array element over here, or you can drag it from here, or drag out the array element get node here. All of this will be fine. We drag out and search for get instances overlapping. You can do a box or a sphere. I'll do a sphere. Now, the location of the sphere will be our overlapped actor. So I'll grab that and do a simple get actor location node. And before I plug this in, I want to make one quick note. And that is the center of your player or any character is not on the ground. It is in the middle of that capsule component, which means that as a sphere, you might want to drop it lower to the ground. Because if you have, let's say, a 5,000 tall character for whatever reason, and you're trying to do just a radius around them of like 100 units, it will never even reach low enough to affect anything near the ground. So maybe you'd want to drop it down. So at this point, what you could do is just do a simple subtract here, and let's say drop it down 100 units, and then put that as the center. So the center will be near the ground instead of actually up in the air. It's entirely up to you, of course. The radius here, I'll say to something like 150, and we want to make sure the sphere is in world space, of course. So from here, I'm going to right click on this array and promote it to a local variable because we don't need it outside of here. And this is going to be our overlapped indexes. And that's going to go in right after this array element. So now from this, we can do a simple for each loop again. Then we want the array element, which is our instance static mesh component. I'll drag out of it and search for get instance transform. It wants the instance index, so that's where we're going to plug the array element into. And we want to make sure it is in world space because, again, we are getting everything in world space, so we want to be consistent. And then from here, I'm going to drag out and use a spawn actor from class. And the transform will be the transform of the actual instance that we're spawning. So it spawns it in the exact same location. Now over here, you might think you want to spawn in a geometry collection actor, like we did in the PCG graph. And this is where things get a little bit weird. For some reason, you saw that I can set the navigation inside of PCG and spawn it with that navigation change. Now, I can even spawn it, dragging it out and change it in the detail panel. But for whatever reason, and maybe I was doing something wrong, I could not, for the love of me, get those changes to propagate in the world when I was spawning it this way. If I spawned it using a spawn actor from class, for whatever reason, the navigation stuff, the collision settings I changed, none of that stuff would be propagated and actually take effect. Now, it would show that it's actually changed, but it wouldn't actually be when I check the navigation and things of that nature. Which is why what I'm going to do is create a new actor with the settings I want and spawn it already with the settings. So what I'm going to do is, right next to the geometry collection crystal here, I'm going to right click, grab ourselves a new blueprint class, actor. This is going to be our BP destructible crystal. And all we need to do is take this geometry collection crystal and just drag it into the components. And you can see there it is right in here. Now I can select it and I can search for navigation. I can turn off can ever affect navigation. If I want to, I can also change the collision here. So for example, I can make it so the little pieces do not affect collision. So I can actually, if I want to, ignore pawn collisions. So when it breaks apart, it will not actually hit the player. Now, I'm not going to do that. I'm going to leave it by default, but you absolutely can. But if you were to try doing this here by doing, again, geometry collection actor, and then search for set collision response to channel. If I was to try to do this and change, for example, pawn to ignore, for some reason, this does not work. Again, from the spawn actor, none of this stuff worked, which is why I resorted to just creating a blueprint that houses this. And then I can set up all the information I need. This also gives me an option that if I want to, I can spawn a random different one of these by just setting it up with a few different options to swap on spawn. So it randomizes which destruction, for example, it uses. So it does have some benefits of doing it this way. But now in here, I'm going to change this to be my BP destructible crystal, and that's what we're going to be using. And then I want to save all of the ones that are going to be actually being spawned here because I want to reference them. From here, I want to make a note of every single crystal that's being spawned. So I'm going to right click on the return value. I'm going to promote it to a local variable. I'll call it spawned destructible crystals. I'll delete the set node and I'll right click on the BP destructible crystal here to make it an array. And then I'll drag it out and do a simple add node to add this instance to the array. So whenever it goes through this array of overlapping instances, it goes ahead and saves which ones of those are actually overlapping once it has spawned it. So then on completed here, on this completed, not the original one, the one after overlapped indexes, I'm going to take our array element, I'm going to drag out and search for remove instances. You want the plural one because this one just takes an array and we have an array, this overlapped indexes. So I'll just go ahead and plug that in and on completed, it will remove those indexes. That means the original meshes will be gone and it will be replaced with these destructible ones. Let's see that in action real quick. If I press play and come here and push this cube in, nothing happens. And if I walk in, look at that. My walking in here is destroying it. Now, you might notice that the color in them is flickering, but that's because I have a per instance material. And I wanted to show you that when this happens, it is regenerating it. And so it is actually going ahead and randomizing it. So you might not want to do a per instance material in this scenario. So just something to keep in mind. The other thing is it's kind of getting destroyed, but not really in a way I'd want. I'd want them not to just topple over. And there's a few ways of doing this. You can, of course, control all the settings here. You can adjust its mass. You can change its damage threshold, a bunch of different things. But I am not very good at this, as this is the first time I'm working with destruction like this. So what I found works a little bit better for me is over here in black in the blueprint graph. Once it's done on this first completed, I'm going to take our spawned destruction crystals and do another for each loop. And on completed, it's going to go through all of them. And then I'm going to drag out of the array element and search for add impulse. And I want the physics one. It automatically grabs the GC crystal that we dragged in and adds that as the target. Now the impulse that I want is going to be from our overlapped actor. So I'm going to use that. And then I'm going to do get velocity, get the actor's velocity. And here, if you want to, you could, of course, multiply it. So if I had a simple multiply node, convert it to a float for the second input, and let's say I want to multiply it by 2, I can use that as the impulse. The only other thing I'm going to change here is I'm going to turn on vel change. If true, the strength is taken as a change in velocity instead of an impulse, i.e. mass will have no effect, which is great for me because I am dumb and I don't understand yet how to probably set it up. So now if we come in here and I run into it, you can see if I run into it with enough strength, it goes ahead and shatters. Now, one other thing is you see it is kind of spazzing around. It's kind of messing with my navigation. things of that nature, because it all still has collision as it's knocking over. And also it's not knocking over enough. So I could go, let's say 5x impulse here. And now if I run in, we start breaking things a lot more. And because again, it is messing with the collision, it's messing with the camera, we can do a few things because it is now a blueprint. So inside of the blueprint destructible crystals, I'm going to go to collision. I'm going to tell it to ignore camera, and I'm also going to tell it to ignore the pawn. This way, I will not be walking on top of the little shards or the little pieces that break apart. And now if I play and I run in here, there you go. It is now breaking apart as I walk through it. And if I walk away, right, here's all the pieces. And because we've told it to disappear after a certain amount of time, you can see now they're all slowly vanishing, the ones that have broken apart and disappearing. And if I go ahead and eject out of here and then select this original piece, you can see these are still instant static mesh components. And every other one that has been spawned is, of course, a regular destructible piece. And while it does get destroyed by me, it does not get affected by anything else like a cube. But of course, if I come a little closer, things shatter and get destroyed and flung quite a bit. So this is all working great. But here's the thing, we still need to stop this timer, because once we've entered it, it will continue on indefinitely because it's just looping. So we want to stop it when we leave the sphere, because obviously if we're no longer within the bounds of the things that can be destroyed, there's no reason to keep tracking it. So what I'm going to do is on this timer, I'm going to right click and promote to a variable. I'll just call it swap crystal timer. And then on end overlap, I'm going to do the same check as I did here. I'm going to check that it is in fact the player from the other actor that is doing this, and it's not someone else that has left the circle. And assuming it is the player, I'll grab my swap crystal timer, and I'm going to do a clear and invalidate timer by handle. So that way, we no longer are running this timer, but that's pretty much all we need. We can reuse this now to be triggered from anything else if we want to in the future. We would just need to swap out the overlapped actor, wherever it's coming from, in this case on the begin overlap, but we can just send it through in another way if we wanted to in the future. Here's my little test demo level. And this is one of my bosses that I'm setting up with this kind of system. And once he is now in phase 2, where he turns this bluish color, once he does the meteor attack, you'll see that he actually is spawning the stuff. So let me wait a moment for him to spawn it. There's the roar, there's the random positioning, and you can see he has spawned these. And I cannot do anything for these, but as he walks into them, he breaks them apart. He does not care. He just pushes them around, and I cannot do anything. And of course, depending on your setup, you'll want to tweak these values. You want to change the way it affects things, the collisions, the overlaps, etc. But hopefully this is getting you thinking about how to actually use the destruction and the fracture built into Unreal to make your stuff a little more interesting in conjunction with PCG. So as you can see, it is quite simple to kind of make an interesting mechanic using this system and tweaking it a little bit for different scenarios. Now, as always, the project file with this will be available on my Patreon, where you can join these wonderful people here in supporting what I do. It really means a lot. And if you'd like to join the community, the link to the Discord will be down below as always. And if you're looking for other cool ways of using PCG, check out this other way of using PCG to create abilities.